Good morning and good afternoon, or even in some cases, good evening to those of you joining us from other time zones. Welcome to today's webinar, Presto, ClickHouse, StarRocks, the journey to real-time analytics at a top social app. My name is Tyler Wishnoff. I serve on the marketing team here at StarRocks, and I'll be your moderator for today's discussion. Now, before we jump into things, a few small housekeeping items. First, this webinar is being recorded and we'll be making it available after the call. Second, time permitting, there will be a Q&A at the end of the presentation. To participate, please post your questions in the chat and we'll go through as many questions as we can when we get to the Q&A portion of the talk. We've set aside close to an hour for today's talk, but if we don't get to your questions, we'll do our best to follow up with you directly after the presentation. But feel free to reach out to us directly should you have any more questions after the presentation. Lastly, we'll be giving away 2 signed copies of Dr. Prashanth's critically acclaimed book, Analytics Best Practices, to 2 lucky winners who attended today's presentation. We'll be randomly selecting them from today's attendance list following the event, and we'll be reaching out directly to the winners within 24 hours of this call. All right, now, with that out of the way, let's get this webinar started. I'm joined today by Li Kang, StarRocks' VP of Strategy, but don't let his lofty title fool you. He brings with him over 2 decades of hands-on engineering experience in the data and analytics space at organizations that include Nokia, Oracle, Redis, Informatica, MapR, and Kylogence. Li has been at the center of some of the biggest advancements in real-time analytics, and it is through those experiences that he's now leading the way at StarRocks, helping to develop the next generation of real-time SQL engines for enterprise analytics. I've had the privilege to work alongside Li at 2 companies now, and we are super lucky to have him with us today. All right, well, now that his ego is massaged and ready to go, I'm going to pass things over to Li to get this show on the road. Li, the floor is yours.
Okay, thank you, Tyler, for the nice introduction. So today I'm going to walk you through the journey of a top social app that for them to take from Presto to ClickHouse to StarRocks on their real-time analytics infrastructure. So this top social app is called Xiao. Actually, the kind of Instagram in China. So I'm going to talk a little bit about this social app, and then I will show you the evolvement of the data platform at Xiao. And then in the last section, we're going to take a look why StarRocks can outperform ClickHouse and why Xiao migrated from ClickHouse to StarRocks. So first, about this social app called Xiao. It's the Chinese word literally translates to Little Red Book. It's a lifestyle social app. Like I said, a lot of people compare it to Instagram. It was founded in 2013. And earlier this year, their stats showed they have over 200 million monthly active users. And I won't be surprised if by now this number has reached somewhere in the 250 million in that range. And their latest valuation is at $20 billion, which makes them the number 16 largest unicorn company in the world. And like most of the social apps, right, their revenue, majority of their revenue came from advertisement. And this Xiao app specifically is also an e-commerce platform. So part of their revenue comes from the e-commerce platform. So that's a very brief introduction about this social app called Xiao. So when they was founded in 2013, right? In the first couple of years, their data volume was still relatively small. So their data platform at that time, they selected Redshift. And like a lot of the early stage companies, right? They build ETL, data modeling, and servicing presentation layer, all from within Redshift. So it's kind of like siloed project, siloed data pipeline within Redshift. That works fine for the first couple of years. And then at about 2017, they started seeing their data volume has been outgrowing their data infrastructure. So in 2017, 2018, in that time period, they introduced a big data platform. Basically, at that time, it was built on top of Hadoop. And Hadoop basically served as their enterprise data warehouse. And they use Presto plus Hive for analytics querying on Hadoop. So that solved the data volume problem. But with the growth of business, and as I mentioned, right, their main business is advertisement placing and feedback and merchandising on their app, on their platform. So customers, especially the merchants, they required real-time analytics, right? They want to see the dashboards. They want to see the latest information reflected on their dashboards and the reports. So in 2019, they evaluated ClickHouse and selected ClickHouse for real-time analytics at Xiaohongshu. Obviously, ClickHouse at that time was considered the OLAP database with best performance in the world, right? So they built their real-time analytics advertisement data center on top of ClickHouse. And then in 2019, 2020, in those 2 years, right, they also started seeing issues with ClickHouse that, due to the technical limitations, ClickHouse couldn't meet their analytics requirement. So in 2020, 2021, they started evaluating StarRocks. And eventually in 2021, they built the new next generation or new generation of advertisement platform or advertisement data platform. That's the project internally that they used, built on StarRocks. So this is their latest real-time analytics platform. So that's the high-level timeline of this, the involvement. And so let's take a look at this advertisement data platform. Right. So this data platform, it's responsible for providing dashboards for stats like unique visitors, page views, live commerce transactions, all this kind of information. And there are two main characters, if you will. One is it needs real-time information. So data needs reflecting the latest transactions on the users' reports, so that merchants can make timely decisions based on the latest information. The second character is this platform needs to support a large number of concurrent users, because the end users are those people setting up shops or trying to interacting with their friends or followers, and those merchants on the platform. So they need to support thousands, tens of thousands, or hundreds of thousands of concurrent users and concurrent queries. And they're analyzing across many different dimensions or attributes, right? Gender, age, devices, keywords, and they have many different level of granularity requirements, from hours to days to months, quarters, right? And probably the most challenging part is business requirement is constantly changing, right? People are requesting new dimensions or new combinations of the dimensions, and they want to try looking at data at different granularities. So there are lots of moving parts here, and that's why it's very challenging to provide a high performance, real-time query or analytics platform that can also support large number of concurrent users. So their previous generation platform, is built on top of Flink plus various different data stores. So this architecture diagram showed the key components at a very high level, right? There are two types of data coming into this platform. One is the advertisement streaming data. That is your ad exposures, placements, click-through rate, purchasing information that's happening in real time and gets streamed over into the platform. And then you have your more like a static historical data, which is your ad effects data. Things like conversion rate, engagement rate, comments, likes, and those kind of statistics. That are, those data is also fed into the pipeline on this platform. And the first step in this platform is is Flink, right? So they implemented business logics, mainly different aggregations, calculations in Java code in Flink. And then data is landed in different data stores. So they still keep MySQL, ClickHouse, and HDFS. And they also use Redis for some real-time applications. So there are different data stores. Then downstream applications, those are like algorithms, billing, and platform dashboards, right? So you can see the main data processing happens in Flink and also the various data stores. So they have built over 20 clusters within the company, and they have over 1,000 data templates for different scenario. And especially in ClickHouse, right? There are over 300 business subject areas. And within ClickHouse, they basically built a denormalized table, or some people call it a white table, flat table, for each and every business subject. So there are like over 300 white tables they were building and maintaining within ClickHouse. The peak ingestion rate was at over 10,000 events per second, and they're getting over 60 billion new events and new records on a daily basis. So that was the previous architecture, and the challenges of that platform at that time mainly came from the Flink stage and the data store stage, right? So on the Flink side, because of all these business logics, those aggregations, computation were developed in Java code and compiled and then deployed onto the Flink cluster. So that increases the development and test cycle. And anytime you have a new business requirement, you make some change to your business logic, you have to redeploy onto Flink, and in that process, you have to shut down the Flink nodes and then restart. So it's a lengthy process and also very rigid process, right? They can't respond to the business logic changes quickly. And also, Flink will vary and degrade with complex logics. And then on the data store side, right, ClickHouse doesn't support high concurrency queries very well. That's a well-known fact. And as I mentioned earlier, right, they had to maintain over 300 white tables, denormalized tables. So maintaining this that data pipeline to feed those tables was not an easy task. And auto scaling ClickHouse was very challenging. And so with more data, more users, it's very difficult to keep ClickHouse with increasing demand. And obviously with different data stores, right? Data gets duplicated across many data stores. So they have to deal with data consistency, data quality issues. So those are the main challenges they were facing with the architecture at that time. The latest architecture that they built in 2021 was built based on Flink plus StarRocks. The change they did was moved all the business logics, right? Aggregations, computation in StarRocks. So made Flink a really lightweight layer. Mostly Flink now is in charge of data cleansing. And then they will just ingest data from the sources and then do the data cleansing and then insert data into a StarRocks environment. So all the business logics happens in StarRocks, and the StarRocks provide a unified data services to the downstream applications. There is still a caching layer, which is basically a lightweight caching layer built on Redis, right, for to speed up the data services. So this architecture is much simpler. Obviously, Flink is now much easier to manage and much easier to scale. The query performance is much better, so dashboards and responsiveness increased a lot. System becomes much more stable, just because of StarRock's simple architecture, and overall, right, the operational cost was significantly reduced. And there's they got rid of the data consistency and data quality issues for the downstream applications. So that is the new platform architecture of the new platform. Just some highlights, the results from this new platform. You can see on the left-hand side, right, we further more detailed about the input data. We have these clickstream data from ads exposure, from clicks and other events. We also have MySQL, which is the online OLTP system. And we can synchronize data from MySQL into this data platform directly. And we also have offline data warehouse for your historical data, right? So StarRocks and the caching layer by Redis, and then the same downstream applications. So the overall query performance, P99 latency is less than 200 milliseconds. The query per second is over 10,000, and the daily number of queries is over 1 million. So all this, these numbers run on this platform, and they were able to build a highly available platform which runs 24/7 without any planned downtime. Why were we able to do this, right? Outperform ClickHouse and replace ClickHouse in this data platform. So let's start with the challenges facing real-time analytics. So why real-time analytics at large scale has been so difficult. The first challenge I will talk about is this concept called a denormalized table. I guess it's something all the data engineers are very familiar with. Most end users don't know or don't care, but that's how we used to get the superb query performance on the with our analytics and query engines, right? So in OLAP or in analytics world, right, we have this concept called a star schema, where in the center you have the fact table, and then you have a group of dimensional tables surrounding this fact table, right? And so the fact is the things that you measure, like the sales volumes, the inventory level, right? Dimensions are the key attributes like time, location, product lines. Those are the attributes that we want to analyze against, right? The challenge is when you query, especially analytical query, run them against this type of star schema or its extension, snowflake schema, the query performance is very slow, right? Join is very expensive. So what people did was, we built a flat table from this, the star schema, right? So some people call it pre-joined, some people call it the wide table, the idea is we're going to break the normalization constraint, and we'll just flatten these records into a flat table. And from there, we can leverage the latest development in query engine, in columnar storage, to give us a much better query performance, right? So most of today's analytical technology use this denormalized table, as the foundation, right? If you look at Apache Druid in their best practices, the first thing they said was denormalize if possible, right? ClickHouse in their tutorial, the first step is converting star schema to a denormalized flat schema. That's in their tutorial, in their documentation, right? So to build this flat table, obviously we added complexity to the data pipeline, right? You have to build extra ETL steps, and you have to maintain those steps. And that adds delay to data ingestion. And for real-time analytics, right, every second counts. And just to build or update this flat table will take some extra time and add extra delays to that ingestion process. Now, obviously, there's all the hardware ETL cluster associated cost associated with building this flat table, and obviously development resources and maintenance cost, right? Those are all associated with this building and maintaining the flat table. But I guess the worst impact is, this flat table doesn't accommodate business changes easily, right? If you add a new dimension or want to make any change to the star schema, you have to rebuild the flat table and redesign it and then repopulate it. So this has been probably the most challenging factor, especially for real-time analytics. The second challenge is in real-time analytics software, most of them don't handle updates very well, right? Here, updates means updating the record or deleting the record, right? Most of our use cases are dealing with inventories, retail, or a financial record, right? Sometimes you have to update a field, sometimes you have to delete a transaction. So for example, in ClickHouse, update or delete is implemented as alter table update, which basically means you have to rebuild a segment of your in your data store and force that into the database. And based on different algorithm they use, right? The overall process is complicated, and the performance usually is pretty bad. And especially if you're trying to maintain high low query latency, and with frequent updates and deletes, that's has been impossible with the other products. So many use cases are just impossible to implement with this kind of technical constraints. The third scenario challenge is supporting high concurrency. Within ClickHouse is its CPU intensive architecture just naturally doesn't support high concurrency very well. So if you look at ClickHouse documentation, default setting is 100 concurrent queries, and most ClickHouse use cases are not suitable for where you need have a large number of concurrent users or external facing applications, right? So for example, in Xiaohongshu's case, they need to support those merchants, which they have tens of thousands, hundreds of thousands of merchants. And this 100 concurrent queries just won't be able to support that kind of concurrency requirements. The fourth challenge is the architecture, very complicated and very difficult to maintain and very difficult to scale, right? So This ClickHouse scale-out issue is very well documented. And when you add a new node to the cluster, you have to do a lot of manual work to scale out the cluster. And also the overall, right, these technologies, they rely on many third-party components from some of the Hadoop components to other external databases to manage the cluster. And usually they will require you to build a quite complex data pipelines, like I mentioned earlier, right? Especially to build the white tables or denormalized tables. So all these add together, right? We're talking about increased total cost of ownership and also bad user experience because of the system's downtime or unavailability. So these are the four, probably I will say, the top challenges facing the real-time analytics products. And so let's take a look at StarRocks. How do we solve these challenges? Just a quick history about StarRocks. The company was founded in May of 2020. The software is available on GitHub, and the community edition is free on our website. So feel free to come to our website, download the community edition, and give it a try. We got a Series B funding of $40 million in February of this year. So in about 2 years, the product right now is being used by about 500 companies worldwide. I listed some of companies here, right? Like Airbnb, like Trip.com, Lenovo. You can see there are some really large internet companies or service providers on this list. So in terms of key capacity, these are also the capacity that to address those challenges that I mentioned in previous slides, right? So the fast query performance, real-time ingestion, high concurrency, and the simple operations. So let's take a look at the each of these key capabilities. First is the real-time query performance. I mentioned, right, the with ClickHouse, you have to build a denormalized table, and ClickHouse just doesn't handle join very well. StarRocks has a great performance for both star schema multi-table joins and the flat table queries. So here I listed benchmark reports for with 2 sets of benchmark reports, right? And these are standard industry standard benchmarks. We used SSB data set and the TBCH data set. So details about these benchmark testings are available on our website. We covers like things like the data set size, the server cluster configuration, and the queries we run, and all the raw data that we collected. So you're welcome to check out those reports and even duplicate those tests in your own environment and let us know what's your results. But anyway, just to summarize the our benchmark results for single table testing, we compared against ClickHouse and Apache Druid, and we saw somewhere in the 3x to 4x, or probably 2x to 4x performance gain based on different queries. And for multi-table star schema type of queries, because ClickHouse or Druid, they don't handle joins very well, so we didn't compare against those 2 products because they couldn't even finish most of the queries. So in that case, we did this comparison against Trino, which was based on the Presto, right? And in that test, we saw somewhere between 2x to 6x performance gain. Because we don't need or don't require customers to build a denormalized table, in this process, we greatly simplify the data pipeline. And also, this opens door to a lot more use cases in real-time analytics, right? For example, if you have multiple data streams and you need to join across those data streams, it was impossible without, you have to do the denormalized table. And with StarRocks, we make that scenario possible within, in our platform. The next key capability is these maintain a blazing fast query performance when you have data updates. So on this diagram on the top, you see the typical data pipeline, right? The way they process update is very similar to each other. And at the bottom, that is StarRocks data pipeline. You can see, it's a very simple, just from Kafka to StarRocks and then to consuming applications directly. So whether it's a streaming data from Kafka or change data capture from data source like MySQL, we provide support for complete update and delete functions, and we maintain sub-second query latency even when the data is frequently updated. So that's our unique capabilities, and it's definitely it's industry leading for StarRocks in this area. Third one is supporting a high concurrent table and partition our data and further split into a smaller data structure and how we store them on the in our servers. We can support 10,000s of concurrent users and easily. And we provide resource isolations so that the users won't affect each other. And probably the best part of that is we provide predictable linear scalability for better concurrencies. So that gives everybody in the enterprise or all of your external customers capability to leverage the platform to do real-time analytics easily. Last, but certainly not least, is our architecture. So I mentioned earlier, right? A lot of these products, their architecture is actually quite complex. Different rows of servers, and there are different third-party components that is required. With StarRocks, it's all the components are self-contained. Just everything is there's no dependencies on the external component. Really, our servers or our clusters, you can think of them, as two different layers. The top layer in this diagram, is this orange box, this yellow box in the middle. We call it the frontier layer or front end layer. So that's the tier where we handle receive query requests from the client application, and we support standard SQL language, and we use a standard MySQL. So any MySQL client can speak with StarRocks without any modification, right? So front end tier will receive the SQL statements and parse the SQL, generate the query plan, and identify the executors. The executors, you can think of them, as we call the back end layer. That's where the execution happens, and that's also where we store the data, right? In the if you run it in the native mode. If you run it in the external table mode, like we can query the data lake directly in place. In that case, you can store data in the data lake without even moving them into StarRocks. But anyway, backend servers or nodes function as the execution engine, and it can also be used as a storage engine. So very straightforward, simple, streamlined architecture. And so, the auto scaling is automated without any human intervention. If you add a new FE node to support more concurrent users, you just drop it into the cluster, and the cluster will handle distributed queries to the new FE node automatically. If you add a new backend node, data rebalancing will happen in the on those backend servers without any human intervention, and also it won't impact query experience. Yeah. So all these features greatly reduce operational cost and improved the system availability. So just to as a summary, right? I list these key challenges and major challenges and StarRock's capabilities side by side, right? As I mentioned in the last several slides, denormalized table, used to be a necessary evil. Updates and deletes has always been a challenge for ClickHouse customers. Concurrency support, and also the operating and maintaining the quite complex architecture with a lot of third-party dependencies. These are the reasons why customers have been struggling with real-time analytics, and why StarRocks can make data engineers, data infrastructure engineers' lives much more easier with our capabilities. So behind these capabilities, obviously there are lots of engineering innovations. So I just listed some of the key engineering features. I'm not going into the details of these features, capabilities in today's webinar. One of the great introductory blog is available on our website. So I posted a link to that blog here. That's, I think, a great intro piece about our technology, right? So, these are the innovations went into the product, and a lot of them are either industry leading or innovating, and that's give us the great performance and great capabilities we talked about earlier. And one thing I would we didn't mention in today's earlier in this webinar was this last bullet point, 100% SQL compatible with a MySQL client protocol. Even though Xiao use any standard BI tool, we have other customers like, for example, Airbnb. They use StarRocks to power their Tableau BI product, and without any modification, out of box, StarRocks works very well, flawlessly with their Tableau environment, and gave them the sub-second query latency across all their most of their Tableau dashboards, and the slower ones were finishing in about 5-6 seconds. Those were the slowest ones. So a lot of great features, and you're welcome to check out these deep dive material on our website. We would publish a lot of the architectural deep dives in our blog section. So with that, thank you very much for your time. Please connect with us on LinkedIn, join our community on Slack. I have the and also check out our source code on GitHub. As I mentioned, right, the community edition, which basically have all the core functionalities and the performance capabilities inside the community edition. It's freely available for download on our website. So I put these links in the slide deck, and we'll be happy to share them with you after this webinar. That concludes my presentation. And Tyler, back to you. Maybe we can open for questions.
Yeah, thank you, Lee. So we are opening things up for Q&A now. Remember, if you have a question, I see many of you have been doing this already, please type it in the chat. And if we've missed your question, you can always repost it. But I'm going to go through them based on the order that I have in the chat. Fortunately for, I think, us.
Tyler, maybe you want to introduce the other two speakers or on the panel.
Yeah, I believe we have Peter Pang, who's been very diligent in answering questions. And the other, Kaisen, Kaisen Kang, who is also here. We're very fortunate to have him here because he is, I think, our foremost expert on StarRocks. So if there are any questions that remain, please post them in the chat. I've got a few that actually DM to me that I can read out. Yeah, again, if you have any questions, please post them in the chat. We'll get to them right away. Again, we've got our experts here, so anything you got would be helpful. Yeah, so we've got, you mentioned Tableau integration. What about Click and Sense?
So yeah, since we support standard SQL, so as long as you pick a MySQL compatible client or library, we can support those BI products.
Questions that I had sent to me. Is StarRock's materialized view updated in real time?
Yes, they are. That's one of the main differentiator, I would say, of our materialized view is being able to automatically update it with your the incoming data updates or deletes.
Great. New one just came in. What are some of the best practices of using StarRocks?
I will let either Peter or Kaisen handle that question because they have more experience with the implementation. Yeah,
Peter, Kaisen, you guys can unmute yourselves. You should be able to if you want to answer that question.
Yeah, for the best practice, that's really based on what's your usage scenario, what's your kind of data, where do you storage in, like that. That's different customer may have different usage. But if you review our video from the YouTube channel before and from the Medium website, you can find some use case like we introduced, like from the WeChat, from the Airbnb, from the payment company, from different kind of users, how they use, how the architecture is, and how they process the data, how they do the real-time update, real-time ingestion, multi-table join. So yeah, all the resources are already online. And if you want to know more details, you can join the Slack channel and we can chat together to give you more example and demo. Yeah.
Great, thanks, Peter. It's very helpful. Another question that we had come in, when it comes to scaling out with StarRocks, is there any downtime?
I think that's my question. Yeah, no downtime. Yeah, because we are distributed database. We have multiple nodes, and each of the nodes they have the different distributed logic, and we have the data replica. You can set the default replica number is 3, and you can also back up the data to like the HDFS or S3 storage or GCS like that. So yeah, even the upgrade of the cluster, you don't need to have any downtime. Yeah.
Very good. And the last question that I have is, how can you update data ingestion in columnar storage and still are able to provide good query performance?
Sorry, you mean the real-time ingestion for the query?
Yeah, I think that may be what they're referring to.
Yeah, we have different kind of data ingestion. You can use the like the Flink connector, Flink CDC to consume the MySQL or Postgres or other TP database bin log and real-time insert into StarRocks. And also we provide like the you can send your logs into Kafka or other data into Kafka, and we use the broker load pull the data from Kafka in real time. And also you can write yourself like the Spark program or Python program to pull the data, do the ETL by yourself. So the latency between the data ingestion from the data source to StarRocks is sub-minute level to second level. After the data are write into the StarRocks, you can query them immediately. So yeah.
We just had another question. How is StarRocks priced?
That's your side, Kang Li.
So as I mentioned, right, the source code is available on GitHub. The community edition is freely available for download and usage and testing. And the enterprise edition the pricing is based on the number of CPU cores. So we'll be happy to do an exercise with you. And then they take a look at what the cluster should look like, and then we can discuss, translate that to a pricing from there.
That will wrap it up for today's presentation. I learned a lot, and I hope everyone else here did too. Of course, if you do find yourself with more questions, you can visit our website at starrocks.com or email us directly at contact@starrocks.com. Of course, also there's the Slack channel too that you can reach out to us directly as well. So keep an eye out for our next webinar, which will feature Dr. Prashant Suthkal, author of this critically acclaimed book, several of them actually, including Analytics Best Practices, which is the book we'll be giving away today after the call. Complete details for that will be coming soon, but be sure to mark your calendars for Wednesday, July 27th at 10 a.m. Pacific, so same time. You really won't want to miss this one. It should be very, very good. Also, be sure to follow us on LinkedIn and GitHub and join our community on Slack, as I've mentioned, to stay up to date with the latest news. And lastly, for those of you who may be attending Databricks Data and AI Summit from the 27th to the 30th in San Francisco this month, please stop by our booth. We'll be there, booth number 747. We'd love to connect and give you a chance to win some pretty awesome prizes. All right, well, that'll do it. Again, thanks again to everyone who attended today. We know your time is valuable, and we appreciate you sharing it with us. Have a great day, and we'll see you at the next webinar.
Thank you.